Hello and welcome. My name's Dave Hicks, and we're about to learn some chemistry. Today's lesson is going to be on oxidation numbers. In this lesson, you're going to learn about the oxidation numbers of some common elements. Then you'll be able to assign oxidation numbers to neutral compounds and polyatomic ions. Now, the oxidation numbers of some of the common elements are these. First of all, any pure element that's by itself has the oxidation number of 0. Now, if the element is part of a compound, then they will have different oxidation numbers. An oxidation number is a way for us to kind of keep track of the electrons so that we can tell what is being oxidized and what is being reduced. And first one here is fluorine. Fluorine is always -1. I don't say always very often. Oxygen is usually a -2. If it's in a peroxide, then it'll be -1. But most of the time you should assume that oxygen is -2. Hydrogen is usually a +1. Again, there's a thing called a hydride out there, and hydrides can be -1, but they're kind of unusual. So you should always suspect it to be a +1 charge unless you have some suspicion that it's different. And halogens, they're usually -1 unless it's with oxygen. And if it's with oxygen, oxygen's going to dominate that oxidation number. Finally, if it's a monoatomic ion, then it's just going to be equal to its charge. Now, if it doesn't fit into one of these categories, then you have to figure out the oxidation number. And that's what we're going to talk about next. So, let's talk about how to figure out what the oxidation number is of different elements when it's in a neutral compound. First thing you need to know is that the sum of all the oxidation numbers for a neutral compound is going to be 0. Because in the end, all of the electrons are going to be accounted for, and they're going to be equal to the number of protons. And I said oxidation numbers are just a way of kind of keeping track of electrons. So here's the way we're going to do it. First of all, we're going to substitute in the values that we already know from those common elements that we just saw a moment ago. Next, algebraically, we're going to set ourselves up a little formula so that we can solve for the unknown compound, or the unknown element, excuse me. And then finally, we'll go ahead and algebraically solve for the oxidation of that unknown element. Here, let's take ammonia to start out with. So with ammonia, I know what the oxidation number of hydrogen is going to be. I know that hydrogen is going to be a +1. Now, there are 3 hydrogens in this compound. I know that the whole thing has to equal 0 in the end, but I don't know what the nitrogen is. So, can you solve for this algebraically? Yep, you got it. In this case, nitrogen has to be equal to -3. 1 - 3 plus 3 +1s, that's what would make it equal to 0. Does this mean that the charge of nitrogen is -3? No, it does not, because nitrogen and hydrogen here are bonded covalently. There are no charges. Again, this is just a record-keeping system, trying to keep track of electrons. Let's try another one. Another nitrogen compound here. And in this case, I have oxygen, and I know what the charge of, or what the oxidation number of oxygen is. It's -2. I only have one of those, so I don't need to multiply it by anything. I don't know what the nitrogen is, and this time I have 2 of those. So I'm going to go 2 times N. There we go. And it's still equal to 0 because this is a neutral compound. So again, let's do a little math here. Yep, I bet you know this one too. Nitrogen here has to be equal to plus 1. 2 times plus 1 plus or minus 2, that'd be equal to 0. I have a couple for you to do. I'll throw them both up here. And you can hit the pause button, work these out for yourself, and then I'll be right here when you get done, and I'll show you what I did to solve for these. Okay, how'd you do? I bet you did great. So for this one, it had a halogen in it, and we know that halogens are minus 1. There's 3 of them. I don't know what nitrogen is, but it's all equal to 0. So here, nitrogen must be a plus 3. And for this one, I have 5 oxygens. Oxygens are minus 2. And I have 2 nitrogens. (10) divided by 2, nitrogen here must be plus 5. Notice nitrogen has all kinds of different oxidation numbers, doesn't it? That's why we can't predict any one particular one. All right, our last topic is how to do this with a polyatomic ion. So in a polyatomic ion, electrons are being shared because it's covalently bonded, but there are extra electrons around there, so we just have to keep track of those. We know how many extra electrons because of the charge, right? So polyatomic ions have charges, and you can see right here in my nitrate example that it has a -1 charge. That means it has an extra electron. So we're going to do this the same way as we did before. Just substitute in our values we already know, set it up, and solve for the unknown oxidation number. Same rules. Oxygen, it's -2. There's 3 of those. I don't know what nitrogen is, but this time the difference is that I'm going to make this equal to -1. So 3 times -2 is -6. It has to equal a -1. So N here, nitrogen, must be plus 5. Let's try another one. I got SO4 here. So again, I know what oxygen is. It's -2 times 4, because I got 4 of them. I don't know what sulfur is, but the whole thing is equal to -2. 4 times -2 is -8. So sulfur here must be equal to plus 6. As always, I've got some for you to try out. Again, hit that pause button. Give these a try. And when you're done, I'll be right here to help you out. Alrighty, finishing off these oxidation numbers, we're learning how to do them with polyatomic ions. Said the only difference here is we're just going to set the thing equal to its charge. So I don't know what carbon is, but you have 3 oxygens. And we know that oxygens are -2. And the whole thing has to be equal to -2. -6, carbon has to be +4. And over here, the hardest one of the day maybe, the oxalate ion. I have 2 carbons. I don't know what they are. I have 4 oxygens. I know they're -2. And the whole thing has to be equal to -2. So this is -8. Bring that over here. I got to have something that's going to be +6. So 2 carbons to make a +6. Carbon here must be +3. So there you go. That's how to assign oxidation numbers. If you want, I also have another YouTube video here that I'm going to be doing on redox reactions, where we'll apply these oxidation numbers and show you what's being oxidized and what's being reduced in a redox reaction. Hope to see you then.